Today we are having another look at some calculus past paper questions. So what we're doing here is we're looking at questions that are combining differentiation and integration. Looking at things where we have to have a little bit more elasticity in our brains in terms of understanding. So starting out with winter 2015, we have a curve passes through the point A, 4, 6, and is such that dy by dx equals 1 plus 2x to the minus half. A point P is moving along the curve in such a way that the x-coordinate of P is increasing at a constant rate of 3 units per minute. So we have a dx by dt here. Find the rate at which the y-coordinate of P is increasing when P is at A, rate dy by dt. So 3 rates, we're looking at a chain rule. Then part 2, find the equation of the curve from dy by dx to y equals, we're going to be integrating. Then part 3, the tangent to the curve at A crosses the x-axis at B, and the normal to the curve at A crosses the x-axis of C. Find the area of triangle ABC. So then we're going to be playing with the gradients again. So going back to the beginning, curve passes through the point A, 4, 6, dy by dx equals this. Okay, so first off, when we want a chain rule, we want to look at what's our variables, and we have here an x, a y, and a t. So the rates involved, dy by dx, they give us dx by dt, we're given a value for that, and dy by dt, that's the one that we're looking for. So dy by dx, we have an expression. Dx by dt, we have a value. Dy by dt, we're looking for. So what we need to do in order to be able to calculate is we need not an expression, but a value. So we want dy by dx at A. A is 4, 6. So our value for x is 4. So at x equals 4, dy by dx equals 1 plus 2, 4 to the minus a half. That is a fairly dodgy looking half. There we go. So square root of 4 is 2, 2 over 2 is 1, 1 plus 1 is 2. So at x equals 4, at A, dy by dx equals 2. Then we need to say, okay, we've got our values. How do they relate within this chain? So we look for the variable that's on top and the bottom. We have an x on top, we have an x on the bottom. So these two belong together. We therefore know that dy by dt equals dy by dx times dx by dt. And we have that appearance of cancelling. Now, they do cancel, they look like they do. And now we're ready to go ahead and substitute some values in. So dy by dt equals dy by dx at A is 2 times dx by dt we're given is 3. So dy by dt at A equals 6. And our units here would be the same as for dx by dt of 6 units per minute. So a slightly different chain rule in that they gave us the dy by dx and then we worked from there. So from differentiation, the chain rule, to integration, finding the equation of the curve. So here we have dy by dx is the same, equals 1 plus 2 x to the minus a half. Now, in order to get the equation of the curve, we've got to integrate. Dy by dx integrates to y, and then we get x plus 2 divided by a half will be a 4. So we've got a 2x to the half over a half, but you are going to get the point where you can do that more smoothly in your head. And then, of course, if we're integrating, we have a plus c because we don't have limits that we're working with here. So y equals x plus 2 divided by a half is 4, x to the half is a root x plus c. We need to calculate that value of c in order to get the proper equation of the curve to locate exactly where it is. So back to our question and a reminder that we pass through the point A for 6. So that means that we can substitute we know that 6 equals 4 plus 4 root 4 plus c. So 4 plus 4 root 4 will give us a 12, 6 minus 12, so minus 6 equals c. And therefore, the equation of our curve is y equals x plus 4 root x minus 6. So it's really important that as you're working through your lessons, as you're working through your exercises, don't get bogged down in just one technique. And it's the beauty of doing past papers is that you start to mix up the techniques, mix up the concepts, mix up the chapters so that you can bounce from integration to differentiation, because you may well be bouncing between the two in one question. And you always got to remember which direction are my exponents going? Am I going up or down? Am I dividing or am I multiplying? Because you don't want to get so stuck in a rut that you go in the wrong direction. So now moving to the last part of this question, where things get rather interesting. The tangent to the curve at A crosses the x-axis at B, and the normal to the curve at A crosses the x-axis at C. Find the area of triangle ABC. Now, we don't really know what this looks like yet. We don't know where B and C sit. We know that we've got a curve, we know we've got a normal and a tangent, and we know we're both crossing the x-axis. But we don't know quite what the story is. So the first place we need to start out is the equations of the tangent and the normal, because that is then something that we can build into understanding what this triangle looks like. So for the equation of a tangent, we never want to be over-calculating. Remember, the point A is the same one we worked with at the beginning. So if we go back here, we did the gradient at A. When x equals 4 at the point A, the gradient of the curve is 2. So therefore, gradient of the tangent is also 2. So we know that mt equals 2. Equals dy by dx at A. And we're going through the point 4, 6. Again, we've worked with quite a lot of information, so we want to be a little bit slow down and make sure that we build these lines correctly, because the whole entire rest of this question is going to depend on these lines we build. So we then label clearly tangent. Y minus 6 equals 2, x minus 4. Still using that same equation. So y minus 6 equals 2x minus 8. Y equals 2x minus 2. Now we have the equation of our tangent. We're going to do an x-axis intersection with that, but first I prefer to get the equation of the normal as well, and then I can do my intersections together. So similar approach for equation of the normal. We would have mn equals minus a half. Flip it, change the sign. Because mn, mt equals minus 1, the perpendicular relationship. And we're still going through the point 4, 6, but we are building good habits. So now we get to the point where we can build the equation for our normal. So it is very simply a case of normal and repeating the same process with the same friendly formula. So y minus 6 equals minus a half x minus 4. So clearing our fraction, 2y minus 12 equals minus x plus 4, opening the bracket. So 2y equals minus x plus 16. So now we've got the equation of the normal and the equation of the tangent. We can actually look now for those points B and C to understand what our triangle looks like. Systematically letting our examiner know exactly what we're doing. So for B, remember in the question they told us that they are crossing the x-axis. Both the normal and the tangent are crossing the x-axis. So working with the tangent to get B, we have that 0 equals 2x minus 2. So x equals 1 and B is the point 1, 0. For C, we're working with a normal. So we have 2 times 0 equals minus x plus 16. So x is just going to equal 16. So C is our point, 16, 0. So we've now got the coordinates for A, B, and C. And we don't want to rush off and just calculate a whole lot of lengths and then work out the area of this triangle. We want to actually first sketch and understand what this triangle looks like. So, for area, triangle ABC, we have the point A, which is 4, 6. So then we have intersections with the x-axis. B is at 1, C is at 16. So we have B, 1, 0, and C, 16, 0. We know that the normal and the tangent are at right angles. So we could go length of AB, length of AC, and get those perpendicular lengths. But there's an easier way to do this one. Remember that A is straight up, okay, from the x-axis. And we know this length here. And we know this is also perpendicular. So taking a moment to think first, the area of triangle ABC equals 1/2. The base is from 1 to 16, so it's 15, times perpendicular height is just our y coordinate of A. So 1/2 times 15 times 6 gives us exactly 45. So the area of triangle ABC, 45 units squared. So we've dealt with a few things in this question. We've dealt with the chain rule and understanding how all the rates are connected. We've dealt with a relatively plain and simple integration. And then a real understanding of gradient for tangents and for normals. And then at the very end, it's that stop and think. So I picked this question because that stop and think comes at the very end. And it's really important that you don't just get into sort of mindlessly calculating things, that you always got your brain turned on and that you're always alert to what you're doing and all the possible things that are going on. So always take the time to sketch, even if it's at the end of a question rather than the beginning. Are we happy with this question? Okay, cool. So then let's move on to the next one. All the way back to 2012. A curve is such that the second derivative is minus 4x. The curve has a maximum point at 212. First, find the equation of the curve, and then a point P moves along the curve. So our second part of this question is very similar to the first question that we did, but there's a few things to look out for. So why did I pick this one? It's because we have got a second derivative and we're working for a full equation of the curve. So we're going to be integrating twice. And that means we're going to have to work with two different constants. So we know that the second derivative equals minus 4x. So for dy by dx, let's work on him first. We have to integrate both sides. So dy by dx Integrate the second derivative, you get the first derivative. Equals minus 4 over 2, so minus 2x squared plus c. Now we're not going to put 212 in here because 212 here is xy. So that's not going to help us. We need to know about gradient. We have a relationship here between gradient and x. Maximum point, that means then that dy by dx equals 0. So we can even state it here. At x equals 2, dy by dx equals 0, maximum point. Then it's a very clear indication of exactly what information we're using and how we're putting it in. So 0 equals minus 2 times 2 squared plus c. So 2 cubed is 8, so c equals 8. And therefore, dy by dx equals minus 2x squared plus 8. But we're going all the way to the equation of the curve itself. So we need now for equation of the curve. Again, we integrate. Dy by dx becomes y equals minus 2/3 x cubed plus 8x plus, and we don't use c again. We use k. C has a value. If we were to put c here, we are saying that the constant here is 8, which not necessarily is. So we need to use a different constant when we integrate a second time within one question. So now we're using that point. We have an x and a y. We have an x and a y. So we're going to substitute that to 12. So we can say here that we're going through the point to 12. So therefore, 12 equals minus 2/3 2 cubed plus 8 by 2 plus k. So 12 equals, and when we evaluate all of that, we get 32 over 3 plus k. So k equals very simply 4 over 3. Now we've got the constant for our equation. So therefore, equation of curve y equals minus 2/3 x cubed plus 8x plus 4 over 3. Coordinate geometry, we leave all our fractions top heavy as they are. And we have our final answer for that equation of curve. Working through two sets of integration with two different constants. On to the last one. Why is it different? A point P moves along the curve in such a way that the x coordinate is increasing at 0.05 units per second, so dx by dt. Find the rate at which the y coordinate is changing, dy by dt, when x equals 3, stating whether the y coordinate is increasing or decreasing. So here we have to take a little bit more note of our sign. We're not just going to give a final answer from our calculation. We're going to take that answer from our calculation and we're going to say, this is the rate, it is either increasing or decreasing. So again, our variables are x, y, and t, and our rates are dx by dt, dy by dt, and dy by dx. Okay, dy by dx we got on the way through in this part of the question. So we do have it available to use. So we have a value for x. We have a value for dx by dt. We're looking for dy by dt, dy by dx. We're going to be able to get a value for. So which are the two that belong on the same side of our chain? We have x on the top and x on the bottom. So let's set ourselves up with the values that we need. At x equals 3, dy by dx equals, dy by dx was minus 2x squared plus 8. So minus 2, 3 squared plus 8. So dy by dx equals minus 10. Our chain is dy by dt equals dy by dx times dx by dt. So dy by dt equals dy by dx is minus 10. Dx by dt, they gave us 0.05. So dy by dt is minus 0.5. So what is the rate of change, and is it increasing or decreasing? So we know the rate of change is 0.5 units per second, and it is a minus. That indicates to us that it is decreasing. So we can say then the y-coordinate is decreasing at 0.5 units per second. So because we say it's decreasing, we don't then say the minus, because that would be a double negative. So it's just the decreasing at 0.5 units. So again, it's always important to read those questions ever so carefully, because you want to be sure that you are answering the question in precise detail. What exactly are they asking you? This question is very similar to the first one we did, but it's actually got a very big difference in the answer. So to be sure of getting that answer mark, you need to give a relevant answer. So as another point to note, as you're working through past papers, you'll find similarities between questions. There are often similarities between questions, but don't, when you get into your final exam, or when you're doing your mocks, or when you're doing papers under test conditions, don't switch into that, oh, I've done this before mode. Always read your questions as if you've never seen them before, because there can be such subtle differences which make big differences in your answer. So it's really crucially important that you read every question very carefully and you answer the specific question that is being asked, not some other version of it that you've maybe seen before.